everyone, welcome to RoboJacket's Technology Enrichment Sessions, part 2 of our CAD series. I'm Sarah Storr. I'm the project manager of RoboJacket's Outreach here at Georgia Tech, and this is Trevor Davidson, a second-year mentor at G3 Robotics 1648, and he is here to help you puzzle through advanced CAD. So if you'd give him a round of applause, we'll go ahead and get started.
How's everyone's day going? I don't know. I've had a pretty fantastic day. I woke up this morning on my friend's table. Yes, you heard right, table, not couch. The couch was taken. And then I went to the G3 team social. That pretty well actually lets me know who's in the room. I mean, like I recognize the 2 people that are here, so thank you guys for coming and showing up. But then beyond that, I came here, and this makes my entire day. I love presenting to you guys. But we're going to go right into topics. I'm going to skip the why do we do CAD, because that's on the last presentation. If you want that, it's archived. Should have come in an email. But these are the topics we're going to go over today. Work planes and axes, just to get a refresh. I think for an advanced course, if you guys are familiar with CAD, you should know most of work planes and axes, but I'm going to go over it because it's going to kind of bleed into everything else we do today. Gears, belts, kind of the most important of the session, that you're going to use, most fundamental things you're going to use more often than not. And you should get, even if you don't ever use it, you don't necessarily have to, you should be able to pull some concepts from this to actually apply to your robot. Sheet metal and threads and stress analysis. Again, some things you might not use ever, some things you don't necessarily need, but it's pretty cool to have, pretty cool to know, and can give you some really good data. And then if we have time, I'm going to go into renders. That's great for presentation material. Absolutely fantastic. We did some good work from my high school team. We did some great work with renders. We got some awards from it. So definitely, if you want to learn it, it's all the resources are online, like I said before. But we're going to try to cover it today if we can. All right, so before you do anything else, this is kind of an extension of the critical 3-point slide from last week, but it's mostly just about thinking. If you guys have seen that one before, you kind of understand that if you want to figure out what you want to do before you want to do it, because if you're just kind of going aimlessly in any direction, you're not going to learn what you're trying to do. You're not going to get where you're trying to go. For example, let's say I want to build an elevator. I just don't start CADing it. I need to figure out what are my critical dimensions. What do I need? Where am I trying to go? Before I can even just start CADing this thing. And then secondly, you want to know, if you don't know how to do something, like I said before, it's all online. Everything you were trying to do has been done before. So definitely look and find the things that you can learn from this. Because they're out there. They're plenty. I did some looking up earlier today. There are like 100 videos, and I did like 1 search. So we're just going to kind of jump into the demo. Pretty straightforward. Much smoother than last week. All right. So first thing we're going to go over is work planes and axes. Nothing too spectacularly different. You can find them pretty much in plane, and they're going to be in various different locations, depending on what file type you're in. Opening up a standard. You'll see them in work features here in 3D model. And then in pulleys and gears, they'll be in assemble. They should also be in 3D model. So you're pretty much, if you look for the 3D model tab, you're pretty much always going to find them. But you can also find them, for example, in assemblies and assembly. And planes are pretty simple. They're just a collection of 3 points that are not collinear. So you can kind of just put them anywhere, basically. If I want to use this point, and this point, for example, there's a plane. It just magically happens. Obviously not magically, but that's the idea. So, and the cool thing about planes is you're not just limited to using points to create planes. You can also use other faces. So let's say I wanted to create a face on top of this sheet metal right here, or this tube. And then I click and drag. I can actually lift this plane off the surface and create an entirely different plane, an entirely different location. So like basically using a reference plane to create a new one that I'm going to use for reference of a part model. And that's kind of your most critical thing. You're going to use that a lot for using belts and gears. They need a mid plane. That's what's going to be kind of your fundamental point to reference base off of. All right, like I said, pretty short. Not going to go into too much detail. Work plane, the plane feature kind of goes into like many different. It can do tons of different options. Like I said, the one at the top is going to cover all of them. If you know how to do it in the other ones, it's just going to be the exact same function. But these kind of limit what you're looking for, so it'll limit your selection options and make it a little easier to screen what you're choosing. All right, I'm not really going to cover axis too much. You don't really need to. There's not too much fundamental to that. All right, So we're going to go right into gears. I'm going to open a new assembly drawing. Just going to do a standard, nothing too feature. Go right to design. You'll find spur gear right here. You can also find worm and bevel gear. I'm just going to cover spur gear here today. Those are your traditional 2 gears like this, gearbox gears. But you can obviously go and work to worm gear. They're not too different. OK, sure. Yeah, whatever. I just want you to save it before you do that. All right, so spur gear component generator. This is going to be your main interface, and it's got 2 tabs, design and calculation. Calculation is going to go over a few different more engineering-based specifics. Design is much more simple. Let's get to the point. Let's get what you wanted. Let's get the visual representation of what you're looking for. Keep in mind, this isn't the only way to do gears, right? So not only do you have the other features that you can use in this program, but a lot of companies, for example, Vex, have their gear CAD online. So if you need to swipe their gears, you can do that. And then you don't have to use this component generator. So this is a cool way to do it. It's really effective if you know what you're looking for. But there are other ways to do it, so don't panic. So what are your critical features here? I'm going to kind of go over the things that cover everything. Diametral pitch sounds pretty intimidating, right? What does that mean? What could that possibly be? It's pretty straightforward. Basically, you have this thing called a pitch diameter. What that is, and the best way I can describe it, is let's say you have a gear. Right? The pitch diameter is kind of the midpoint along the teeth. Why does that matter? When you have 2 gears mesh, the pitch diameter is what's going to be tangent to one another. So then how does that relate to diametral pitch? Right? Diametral pitch is just a ratio. Where n is the number of teeth on the gear. So when you see this, it's like you try to do some Googles, and it's like, what is diametral pitch? You can't find it. That's how you figure it out. So it's a complicated way of saying pitch diameter. Other things. So pressure angle. That's actually a really good picture on the internet for this. Right here, you can see that pressure angle is basically the angle is the same thing as the profile angle, just in a different context. Profile angle is when you have the vertical straight up to the edge of the corner of the tangent point of the gear, and then whatever the tangent line is. So for example, let's say you have a gear tooth. Right? From the center point here, it just comes up like that. Your pressure angle is going to be tangent right here. And that's what your pressure angle is going to be. It's not necessarily too complicated. You can pretty much leave everything in here, unless otherwise specified. But it's something good to know. So you don't like, oh, what is this? Can I just change this randomly? You might be able to. You might not be able to. So keep that in mind. Helix angle is actually really cool, and I'm going to get to that in a second. But we're going to cover that pretty quickly. You don't really have to worry about total unit correction too much. It's not going to be a big deal. I wouldn't even consider it. All right. So then what do you have? Design guide. That's going to be what you want out of the design feature. So for example, center distance right now. And you see the center box center distance right here. You'll see it's kind of grayed out. Whatever you put in the design guide is going to be the thing you can't put in for. Everything else is going to compute for it. So if you want number of teeth, you can see center distance opened up, and the number of teeth in both gear 1 and gear 2 just kind of disappeared, right? So you want to use this one. What are you looking for? That's what you're going to need to decide. So let's go with number of teeth. Why not? And say our desired gear ratio is 3 to 1. Right? You can just enter 3. It's going to automatically assume 3 to 1. If you're looking, it depends on what kind of gear you're looking for. I'm going to uncheck this box for now. We'll come back and check it later just so you guys see the difference. And you'll see number of teeth is still closed. Face width, that's going to be how thick is your gear. So if you want a 1-inch thick gear, that's what you change that to 1. 2, I'm going to leave this at 2 just so you guys can see the difference. Unit correction, another one of those things you just don't have to worry about. And then right here, see component feature, no model. Don't worry about feature. That's not really too important. But no model is useful because what it allows you to do is create one gear. Instead of having to create 2 gears every time, you can just say, I want the top gear, I want the bigger gear, or I want the smaller gear. So just kind of pick the one you're looking for. We're going to leave it at component right now, so it'll create 2 separate gears. But we're not going to, but we can change that later, and so just obviously show what it looks like. Click OK. You can click Calculate too if you want to do that. That should clear up the number of teeth. You can see 20 and 60. And click OK. Sure, whatever. All right, there we go. Just kind of click to place, and that's it. Right? You can see it created the gears. It didn't create any holes or anything. You have to go and add that after. It's not designed to put that information in. But if once you do get the opportunity to do that, you can create sketches and things like that on these faces. So it's not, don't worry like, oh, I can't do anything with this. No, you can still use all of the normal modeling stuff with it. They're also one part, so you can see just as an assembly right now, they're together. But if I click right here, it gives you both individually. So you can save those part files and then have them later and just steal one of them at a time. You don't have to worry about using separate. You don't have to take this entire assembly and that's it. OK, so that's it for now. But we're going to go back, open this up. Right? OK, so you said I was talking about helix angle before, right? Well, here's the neat thing. So what is a helix? Basically, have you ever seen some team go, wow, that's a really cool gear pattern? And it's like they have this gear pattern that's like this, and the teeth aren't these straight up. They're like diagonal. Oh, wait, that's not a good drawing. They're like diagonal. They like go down like that instead of like that. It's pretty cool. Well, this is how you do that. So let's say I put in 10 degrees to make it look kind of obvious. And you kind of want to keep it low generally. You don't want to go above, I don't know, 45, 30 degrees, because it's going to kind of look funny. It's not going to give you the most force in the direction you want. But let's just hit OK for 10. Again, hit OK. Click, and you can see what changed, right? Versus this one. You can see the teeth are straight. We go back into our other one, and the teeth are definitely not straight. That's pretty neat. It allows you to create some pretty cool gears, especially if you're 3D printing these. Looks fantastic. But it's also pretty useful. And you can see also, before I didn't point this out, but the face width is different between the 2 gears. You got your gear 1 is different from your gear 2. And that's going to kind of apply universally. Vex doesn't sell consistently sized gears. AndyMark doesn't sell consistently sized gears. Sometimes you're going to want to change it up, depending on what your needs are. Alrighty. That pretty much covers the gears. Is there anything else I need to go over? I think that's pretty much it for gears. OK. Any questions on gears? All right, cool. Let's move on. So I created this little assembly before. It's just an AndyMark pulley I grabbed off their website. I can't tell you what part it is. I have no idea. I just picked one. And then a couple quick parts I threw together. Nothing too special. But we're going to go into pulleys. So that's not what I need. I need design. Under V-belts, that's going to be kind of one of the things you're going to look for, but you're not going to want to select V-belts here. Although V-belts and synchronous belts are pretty similar, they're not going to be necessarily the thing you want. You're going to more look for, if you're doing belts, you're going to choose synchronous and roller chains. So in this case, we're just going to do synchronous belts. Like I said, V-belts are kind of the exact same thing. They're just a different style of belting, and then chains are obviously chains. OK, so you see pretty small, much smaller dialog window than the past one. And that's going to help. It's going to make things a lot easier to deal with, and it's much more click and drag. So first thing is what kind of belt are you using. They're not going to say, oh, this one from Gates, this one from AndyMark, this one from Vex. It's not going to say that. It's going to have specific kind of styles. So you might want to play around with it a little bit, figure out which one's which, what are you looking for. But again, it's one of those things that this is going to be more representation than anything else. So kind of don't make this like a sticking point. Kind of think about it, but don't worry about it too much. Probably the bigger thing is you single-sided or double-sided and what size you're using. So just kind of think, am I using this tiny little belt I'm using for gear, belt and tube, or am I using a much larger, like this big belt? That's going to make a difference. So We're going to go down. We're going to pick this one. Single-sided large belt. Doesn't really make too much of a difference. Belt mid-plane. Basically, when you think about a belt design, right, you don't normally, with the exception of, okay, I'll get to the story in a second, but basically when you have a belt, right, that's kind of how the generally looks. The belt midplane is where the belt is going to run straight down. So if you put the belt midplane at the point you don't want, it's just going to go in this random direction. So the belt midplane is really, really important. For now, we're going to go into, kind of click that button like you would if you're doing an extrude or something. Go down to, I'm just going to select this face for now. Again, that's not what we'd actually do. We want to select somewhere in the middle of that. But that makes our lives easier for now. So you can see it kind of created these two random pulleys, right? You're like, why is it doing that? So Inventor chooses, once you need to select a belt midplane first, and then it shows you a preview. Well, you don't have to choose to create pulleys. You can just create the belt, but it does allow you to create the pulleys at the same time. So if you can knock that out at the same time, it makes it really easy. And they do, similarly to the belts, they do give you a few different styles of pulley to pick from. They're not specific. You can't say just like, I want the Vex 20-tooth pulley. No, it's not going to work like that. But you can kind of get close, and then you can play with it later if you need to. We're just going to kind of ignore that for now, because we want to go to this thing. It sees component existing virtual. Ignore virtual. It doesn't really matter. But component and existing are the two important ones. Like there was no model before. Existing is what we're going to choose here. What that means is that we have a pulley there. We don't need a new pulley because there's already one in our drawing. So we don't have to worry about that. You can see the preview eliminated the first pulley, right? So then with this existing pulley, we just kind of click somewhere on the drawing that we want the belt to go around. And you can see kind of goes around the outside of that now. So we're done with that. We're going to do the same thing with the second one. It's like the same kind of face. Not sure why it's red, but you get the idea. Normally it'll be green. Not sure why it's red. You can also switch the direction of travel. And you can see the red arrows right here. That's going to tell you which way the belt's going to move, theoretically. Again, it doesn't make too big a difference, but you can switch between the two of them. So it makes it a little cool thing to play with. Also, like in gears, you have this calculation tab. I'm not going to really touch on too much of it, just except the torque, speed, and service factor efficiency. Those are kind of easily found on the internet. You want the power and torque combined to give you a speed, or the power and speed combined to give you torque, my bad. And that's pretty much specified here. So you can play with it. It's going to be useful. The tension factor, again, depends on how you're getting your data. If you're getting a belt from calculations and numbers, then this is going to be what you're looking for. If you're looking for a basic design, which is going to be what you're on 90% of the time, this is what you're looking for. All right. You can also add a third pulley. If you click to add pulley, you can choose, hey, I want to add that pulley right here. Now you have 3. You can continue to do that 4 or 5 or 6 if you have more than one pulley. And you can still choose. It doesn't have, again, you could choose a third existing one. We don't have that, but if we wanted to, we could. We're going to click component. Why doesn't it like this? OK. A lot of times you can kind of ignore what it says it doesn't like, because it'll just do it anyway. So don't worry. Don't get too stuck on that. So you can see it created the belt. The belt is black. I've changed the belt colors before. It's not really worth it. So if your belt is like gray or white, I mean, it's a representation. I wouldn't, unless you really want to do it, you can come up and ask me after the session. I'll go over it pretty quickly. I haven't done it in a while, but I should know how to do it. OK, back here, belt width and number of teeth, pretty straightforward. This is going to be just about the belt. Don't worry about the gears. This is just the belt. So when you click belt width, if I want to do a 3-inch wide belt, say I want to make the midplane there now. You can see it kind of created 2 more pulleys and then created a much wider belt. So you can play with that there. Number of teeth, I think it's pretty obvious. All right. Get rid of that. Didn't really get what we wanted. So let's create an actual belt now. Go in 3 model, pick plane, kind of move this over to what we think it's going to be. It's not quite an inch. We'll kind of put it at negative 0.75, my bad. Negative numbers are accepted. Click OK. There you go. There's your belt midplane. Go design, synchronous belts. We'll leave it what it is right now, not too big a deal. Select belt midplane. See, it creates pulleys. We're going to go back to 0.75. Number of teeth, massive numbers to play with. We're going to stick to 66. And we're just going to do what we did before. Click there. Go to existing. Click there. OK. All right. There you go. There's your belt. Pretty cool, right? Like I said, it's mostly useful as representation. You're going to want to do your calculations separately, but it's still a pretty useful tool. As always, you're going to kind of want to turn off your work planes just because it looks a lot better without them in there. You should also be able to turn off these axes. I can't exactly remember how now, but that shouldn't be too hard either. Alrighty, any questions on that? Yes? Well, generally no. So it doesn't make it automatically turn. There should be I'm not going to cover it now, but in the assembly there's a rotation command, like rotation instead of mate, there's rotation. That should be able to do something like that, especially with gears. I haven't tried it with pulleys, but because of the way the belts kind of look, as you can see, it's pretty simple. It's more, like I said, it's more representation than anything else. You can pretty much just make it so that if you put the 2 pulleys together and you make them rotate together, this should rotate together. All right, cool. We're going to move on. I'm going to go to sheet metal. This is one of my favorite topics. In high school, my team did a lot of sheet metal, so this was something I used pretty often. One thing about sheet metal before I go into it too much, a lot of these features you can do just regularly. So like you can see there's like the cut, flange even. You can kind of do separate these things all through extrudes or sweeps or revolves, whatever you want to do. A lot of this can be applied through regular commands too, but these tools make it so much simpler and so much more effectively done that when you send it to a supplier, they're like, wow, this is pretty great. Versus if you just did revolves, they can see error here, error here, error here. This isn't going to work for us. Send it back. So I would say whenever you're doing something with sheet metal, this is the place to do it. So the first thing you want to do whenever you open a sheet metal part, especially if you haven't done any before, is click sheet metal defaults. It's going to give you this little pop-up box. And under sheet metal rule, it's going to give you like a couple options, default and default millimeters. There isn't really too much of a difference. It's just one's in metric, one's in inches. But I would click this pencil right here. It depends on what you're doing, but you can kind of make it faster for everything. It's going to load up a menu. It's your standard style and standard library editor. Basically what you do here is you want to create your own custom sheet metal rule. If your team just uses 1/8 inch and 16th inch metal, why do you need to have to enter that in every time? The default for the standard default is 0.12, or if let's say you use 5mm metal, this is 0.5. So you can kind of create your own defaults and make life a lot easier and a lot faster. So click New. It's just going to kind of copy of default. We're going to just go quickly. Let's say this is 1/8 inch thickness. Okay. Done. Simple enough. You right-click. You click Active. Now, whenever you open a new sheet metal part, that's going to be the one you want that's going to open up. So you don't have to worry about, oh, it's actually the sheet metal default is 0.12. And you'll ask, why does that matter? Well, sheet metal defaults kind of drives your entire system. If you click the face option, it's basically a quicker option of extrude. What that does is it extrudes it to your default thickness. Well, if your default thickness isn't the thickness you're actually using, then what are you getting out of this? So this kind of makes that process entirely accelerate. Material depends on what you're using again. If you're using sheet, if you're using steel, if you're using aluminum, using copper, whatever you're using. In this case, we're going to do aluminum. Thickness, you could kind of enter whatever you want. like I said, we're going to use an 1/8 inch. And then these other menus, you can see some pretty interesting stuff about the process of sheet metal. Those of you familiar with sheet metal will kind of understand this immediately. Those of you not, I refer you to the graphic. It is a very good graphic, so when you guys do this on your own, it would be super helpful. Corner, similar situation. All right. We're going to click Done. Save edits, yeah. You can see it opened it up in the rule here. Thickness is right here. You can also generally, like I said, the process is a lot faster when this is right, but you can also come here and click Use Thickness from Rule, and then select, kind of enter whatever you want. So if you want to do a 1/4 inch, that works too. Apply. We're going to move on. So this is just the same thing as a normal part. Let's just create a sketch, right? We're going to want a rectangle. And we're going to do, it's a good number, 5 inches. And let's say 3 inches. All right. Finish sketch. Simple enough, right? Really easy. Like I said, how face kind of expedites extrude. So since we have our defaults correct, we can just go to face, and it creates it for us. It doesn't put it centered. It'll just put it kind of extrude, the normal first option extrude, but it does accelerate the process. So click Apply, done. Really simple, really cool. What's your most fundamental feature in sheet metal? It's going to be your flange. What is a flange? Think about every time you get some out of the AndyMark kit, right? You have this kind of main face on the side of your robot, and then you have these 2 little tabs at the top. Those are flanges. They're just bends and extensions of your part in a certain direction. And how do you make these? Well, you just kind of, in CAD, you just choose an edge. So you can see it kind of shows you a preview of what you're looking at. Height extents is very similar to what it was before. There's in extrude, it's basically an extended option of that, but this just makes it a lot easier and a lot more clear. The height extents. You can choose distance in 2. If there's another face you're working with right here, all the way over on the side, you can choose that, and that'll make your life even easier. But in this case, we're just going to choose distance, and that's going to be 1 inch. Now, what does 1 inch mean, right? You got this bend curve. That's what you're going to go to this height datum thing. It's going to give you 3 options. The first is going to be from the intersection of 2 outer faces, second from the intersection of the inner faces, and then the last one is parallel to the flange. I think the parallel to the flange can get a little confusing at times because it's not always super clear. I would kind of stick to one of the other 2, depending on what you're looking for. I'm going to just use the first option here. Bend position, I'm going to just choose the first option for now, and you'll see the difference in a second. This one just goes to the inside of the bend extents. And the bend radius is what kind of drives this. So you've got your own default bend radius. You should be able to edit this in sheet metal defaults, but you can kind of go in here and edit it yourself too. So let's say I want to make it a 1/4 inch bend. You can see the curve right here significantly grew. And you can see because of the way we've got our height datum, this also grew. If I do that, it adds more back. You can select more than one edge too. So if I want to do 2 edges, like this bottom one down here, I can do that as well. Click Apply. Pretty simple. And you can continue to do flanges as long as you have edges to do them with. Again, right-click, and you go to Edit Feature, and you can change it. So let's say we wanted our flange angle to be 75 degrees. You can see from the side, it's no longer this flat angle. Then we can do that. So let's do it, just because. That's going to be kind of your main option. But this contour flange is also really cool. As it's kind of explained, it's like a sweep. For those of you here last week, a sweep, you need a path, and you need a profile, right? This is kind of a faster version of a sweep. So here's what I mean. Let's go to the origin and start 2D sketch and select the YZ axis, right? We don't need to project it in geometry, so even though I clicked it, you don't need to do that. Let's go to arc. Kind of select this bottom edge. Come over here. Go right there. Maybe we'll do another arc, and it'll go. Let's make it tangent to the other one. Right? Make this tangent to this face. Make sure this is still tangent to that. All right, it is. Cool. We're not going to play with the other dimensions. Not going to mess with it at all. finish sketch, go to contour flange. The profile in this case is not the same as the profile on the sweep. The profile in this case is going to be your path. It's the same idea. So click there. You click an edge. In this case, we're going to click the one that we made the path intersect through. So that one. And look at that. So like I said, it's kind of like an extension of a sweep. It makes life really easy. So if you're doing things in sheet metal, these are cool tools to have. And you can kind of do, depending on the circumstance here, and you can kind of switch it up what direction you're going in. Generally, you're just going to want to pick this one. It's much less flexible than an extrude switching of the options. And then bend radius is nothing really that doesn't really change too much either. As you can see, there's really no difference. So click OK. Voila. Really, really good if you have some kind of aluminum sheet you're just kind of laying over your robot in some kind of contour. That's going to be the way you want to do it. Way more useful than trying to do flanges or splines and getting it to extrude. All right, those are your kind of the main things you're going to do. Contour roll, nothing really. It's interesting. I would recommend you guys go view it, but it's not too critical. Lofted flange, I think that's pretty obvious. It's basically a loft. But hem is kind of useful. Sometimes you see on parts where it'll just do this little, really quick little bend. Right? What if you need to recreate that? You got this hem, right? You got a few different options: single, which is that, teardrop, rolled, and double hem. So sometimes you'll get parts like this. Sometimes you'll want parts like this to cover up the edge or make it a wider surface. Click the shape, select your edge. Click that one right there. Gap, that's going to be the distance. Pretty obvious. That's going to be the distance right here. And then your length is just going to be this distance right here. So if I put in, I want a 1/4 inch length, you can see that decreases. It doesn't generally, if I put 0, it won't allow it. So let's say I put in a really low number, you can see it kind of just bases it off what's the end of the curve and then add on to the length. Versus the thickness, if I say I want a 1/4 inch, you can see it kind of grows. You can see kind of the differences between them. Apply. Oop, not happy with me. Still not happy with me. OK, we'll go to single. Still not happy with me. All right, we're just going to ignore this. Whoops. All right, so bend and fold. It's pretty interesting stuff. I haven't found it ever useful, but it's pretty straightforward to use. If you have two faces, you can connect them with bend. A fold allows you to kind of create a sketch line and then fold the entire sheet metal part over that line. So instead of having to just do a flange, you can kind of play with, I want a diagonal cut here. I'm going to kind of do a quick example. Let's go to this face, sketch on it, select there, pick a line. We're just going to kind of draw one right here and accept it. I'm not going to worry about the dimensioning right now. We're going to fold, click your bend line. If it's going to let me. Hopefully it will. Ah. OK. And you can see it kind of folds it along the line we chose. For some reason, it wouldn't let me select the green line, but it still creates an additional fold. So you don't necessarily have to go through the flange. Cut. I feel like that's pretty straightforward. That's basically an extrude. There's really no difference that I can tell. Rip. It's pretty cool. I'm just going to kind of scroll over it here to give you guys an idea of what it does. Removes model, allowing a closed model to be flattened. So if you do have this cool thing on the end, right? Obviously, you can't create a sheet metal part by just saying, here's the final drawing. Because the dimensions change when you fold things, right? The inner dimensions, the difference from the outer dimension, the length you have is going to change. The length of your part is going to change when you fold it. So creating a flat pattern is going to be really important. A rip allows you in some certain places where you've done a flange. Like for example, if I do a flange on this edge right here. Well, let's go back. Let's do this edge. you can see it kind of removes a chunk of material. And why does it do that? Because if you don't remove that chunk of material, it'll tear right there, because you're pulling that material in so many different directions that it needs that relief. What we call it is a relief cut, and a rip allows you to just do extensions of that where in different places you want it. Corner round, quarter chamfer, exact same thing as fillets and chamfers, nothing too special there, and you still have your patterns in your hole, so nothing too great. Unfold and refold, kind of individual options for creating a flat pattern. So let's say you only want to unfold this bottom flange right here, right? Let's go to this unfold feature. You need a stationary reference point. What isn't changing? What's your flat pattern? Obviously, it's kind of the first face we started with. Allows us to select a ton of bends, right? It shows you all the possible bends. We're going to select this one down here. Right? And you can see what kind of undoes itself. All the bends that we did with a regular flange, those are going to happen. Hit apply, and you can see that that specific bend unfolded itself. And you can do it again. So let's say we want to pick the same stationary reference point, pick the same bend, hit apply, and you can see now it's completely flat. Pretty cool. And like I said, you can kind of do the refold option too. So if you want a stationary reference, select that bend, and you're back to where you started. So sometimes that's what I find that really useful for is, let's say someone from your shop comes down and says, hey, I really need this dimension for creating this sheet metal part or this plastic part, because you can kind of do the same thing with both. You can kind of unfold it really quickly and give them a, hey, this is where this hole is on the flat pattern, instead of having to go through and make this whole drawing and create a whole flat pattern, yada, yada, yada. Really useful for quick stuff like that. But I wouldn't recommend necessarily unfolding your model entirely, because remember, this is still your part. So if you go into a drawing and paste your part drawing, right? Once you change it, it's going to change the dimensions of what that is in your drawing. So the linking in Autodesk will completely change. But if you create a flat pattern, it creates a separate thing. So if you're putting this in a drawing, use the flat pattern. But if you're just using this in the model space, then I would recommend doing the refold and unfold. All right, that pretty much covers everything in sheet metal. Nothing too special there. Anybody have any questions? All right, cool. Either I'm doing a terrible job or a great job. You guys give me a lot of confidence here. All right, I'm going to assume I'm doing a great job. So, yes?
How often have you used the sheet metal feature on robots?
A lot. So in high school, my team, it very much depends on the situation. For example, Team 1746, I don't know if you guys watched IRI, but they created a completely new robot for their IRI competition. They have a sheet metal sponsor that allows them to create sheet metal parts like this. So features like this are really useful for them, where they want to create flanges and create contours and things like that. It's really useful. And my team in high school was a similar variety of that. We had a sheet metal sponsor that uses a lot. If you're creating sheet metal in-house, this is really useful. If people aren't using sheet metal as much, it can still be useful. You'll just find it less often. For example, on 1648, we do a bunch of stuff with plastic, right? Lexan, Delrin, whatever we want to use. And we decide, hey, let's bend it at a certain point. We're going to do it in here because it's just so much more easy to use. So most teams have access to plastic, and to use features like a flange, you really need a vise, a blowtorch, or some heating mechanism, and like a wrench. So this can be kind of applied to all teams. Some teams are going to use it more than others, but overall, it's still pretty useful. Any other questions? Yes? Pretty simple. So if you go right up here, you'll see these two bars, right? The bar on the left, that's your material bar. So you can choose whatever you want. This is going to impact things like stress analyses, and it'll change your default part look. So if I choose polycarbonate, you can see it kind of changes view. It also changes the material. So if I went into a stress analysis and compared aluminum and polycarbonate with the same thing, it's going to change those factors right now. Your bar on the right is just appearance based. So it has a lot more options, and it gives you kind of a preview right here. So for example, if I click olive green, now I have olive green polycarbonate. So it's pretty fun to play around with when you start painting your robots. That's really fun. That's pretty much it for sheet metal. All right, I'm going to quickly cover threads. So I'm going to go open this and choose axle. Threading is another one of those, hey, it's cool to have, but we don't necessarily need it. Threading in Autodesk is basically just it's a paste-on view. It's going to show you what the threads look like. It's going to show you where something's threaded, but it's not going to say, hey, you're going to create this little threading for you. There are ways to do that. If you do, I would recommend doing coils and things like that. I'm not going to cover those right now, but that's how you do a complete version of that. So we're going to go right here. We're going to go to threads, which should be right here, yes. Thread. Right, so if you click face, you can see it kind of gives you a preview. It just looks like a bunch of bars wrapped around one another. That's going to kind of show you the representation of it, right? You don't click display and model, then it won't really show too much. It doesn't really matter whether you click that or not, but I leave it clicked. And then you have an option to have full length or partial lengths, right? So you click full length, it's just going to be the entire length of your axle, which if you're using a threaded rod, well, that's really useful. But most of the time you're not using screws or something like that. So unclick full length, and you get way more options to play with. So you can see now it's just previewing on the end of it, the thread, versus before it used the entire length. You can see the difference. But we can also change this around. So if we want to offset, let's say we don't want it on the end of the rod. Why do we have it on the end of the axle? Let's put it 3 inches in, right? Click the face feature again. You can see it's shifted significantly. Let's change this to 2 inches and let's make it length 2. Now it's changed again. So you can kind of play around with where the representation is. You can also specify the stuff. So if you want to put a specific thread in there, it should show up. Again, it won't do the actual modeling for you, but it'll show you the representation. So that's pretty cool. Allows you to kind of indicate screws and things like that much more easily. All right, so we're just going to click that, hit apply. You can see it's the same color as my thing. So if I change this to red, the threads are going to kind of change color too. Threads have their own color database, so they don't look exactly the same, but they look a little different. All right, like I said, we're just going to cover that pretty quickly. We're going to go to my favorite thing, stress analysis. We're going to open up, go back, this bracket. You might recognize it from last week, pretty simple bracket. But we're going to use a lot of the cool features here. So if you go into environments, you can see stress analysis on the end. Click that, right? Whole new window. A lot of it looks foreign. Don't worry, it's pretty straightforward. Click create simulation, and that's going to kind of start your process, right? It's not going to let you choose anything else until you do that, except for the settings, but we don't really need to deal with that. So you have two kind of, the thing is you set your name. Generally, it doesn't really matter. If you want to put simulation 1, simulation 15, I like cookies, whatever. You can put whatever you want. So we're going to leave it at simulation 1. Design objective single point. You have 2 options here. I'm going to stay with single point for now, and then we're going to go to the other option, which is parametric dimension. Right? Okay, single point. Static analysis or modal analysis. Modal analysis is going to be vibration based. So it's not generally what you're looking for. You're going to want a static force analysis. So you're going to generally want to keep static analysis clicked. And don't generally choose, unless you know that you want to do this, generally unclick detect or eliminate rigid body modes. You shouldn't have to do anything with that, but just in case. Click OK. And every other option opens up now, right? You get this kind of drop-down menu. These are, in a straightforward sense, these are the things you're going to need to have to run a simulation. Material, if it's already specified up here, you should be fine, especially if it's just one part. In assemblies, sometimes you import models, right? Let's say I want to drag that pulley from AndyMark, and I want to do a simulation on that. A lot of that stuff's going to be generic, because I pulled it from a step file. So then you have to go back, and if you go into material and you click the assign button right here, you'll see an original material. It'll show up there. If that original material is generic, it's going to put up a flag. Generic is just whatever your standard thing is. When CAD doesn't know what material you want, you can kind of choose an override material. So if I want to use aluminum, I can do that. But let's say I want to use the ABS plastic as my calculator instead, I can kind of override it here. So while you're choosing material isn't necessarily the most important thing in your part, it's way easier to do that beforehand and then not have to come in here and do this override stuff. FYI. Leave it as defined. Click OK. All right, pretty cool, right? So now you have to put constraints. What do we mean by constraints? It's kind of the same idea as we did in assemblies. you need to find a point to fix everything and make sure that that section of it doesn't move. So looking at this bracket, let's say we welded the bottom of this, right? Click Fixed, select right there, hit Apply. Okay, pretty straightforward, right? So what that means is if, when I do the simulation, that face isn't going to move. No matter what I do, it's static. All right? So then we need loads. You can have pressure loads and you can have force loads. In this case, we're just going to use a force load. There's a couple other ones to play with, like gravity and bearings. That's up to you to play with. Gravity depends on it really depends on the situation you're doing. But force is going to be the one that kind of covers many more topics. Pound force is the same thing as pounds. So when you see pound force, it's like, oh, is that something completely different? No, it's exactly the same, 1-to-1 ratio. You can enter newtons in here too. So if you need to choose between the two, or you need to convert, this will do the conversion for you. All right, so let's say we just want to do 2 pounds of force, right? Location is already selected. We just need to find a place to put this force. So if we choose this face right now, what it's going to do, I'm not going to change it. But if we choose this face right now, what it's going to do is it's going to apply that force evenly over that entire space. So if we're looking to choose, let's say, we do a washer, and we want it, and we have a bolt through this hole, and we just want it just around this hole, you're going to want to do the split thing I talked about last week, where it's going to create a whole different section. So instead of just choosing this entire face, you're just choosing that little circle. And I'll go back and do that later, but for right now, we're pretty okay. Click Location. You can see it kind of applies it in the center. It's really just going to apply it all over the place. Right, direction, you can kind of apply it in both directions, but we're just going to go straight. Click Apply, and it shows up under your force loads right now. And it leaves that arrow there just so you guys know. But in case you didn't know, it's got that there too. Contacts, don't really worry about it. Mesh, think of a mesh. Someone talked about Minecraft earlier. I don't know who it was, but I was overhearing some people. And think about a mesh as a creation of Minecraft blocks. Every block is its own thing, but inside that block, it's homogeneous, right? A mesh is kind of the same thing. It creates a bunch of different small areas along the part, and then says, all right, it does the calculation in this section, and then does the calculation in this section, until it does all of them, and then you can see how the part model reacts in different locations. If you do simulate right now, we have everything we need, and it'll do the mesh for you, or you can create the mesh beforehand. So you see it computes the mesh, and you can see that's how it kind of works. So when it does this calculation, it's going to do it here and here and here and here and here until it's gone through them all. You can on and off click Mesh View, and it'll show it or not. I'm going to leave it clicked just so you guys can see, and then simulate. One simulation, one configuration. We're only doing one test, so we're going to click Run. It's a simple part, so it goes pretty quickly. But you can see you get multiple different result tabs. Looks kind of scary. Don't worry about it. I'll get to your question at the end of this thing. So what you have right here is you have a sidebar. That's going to give you the units for what you're using. In this case, it's KSI, kind of just an extension of PSI, but you can change that up later. And then depending on what you're doing, it's going to give you different numbers. So for example, if I go to displacement, you can see the unit changes to inches right here. You can see where is this part flexing the most. Right? Safety factor, also really useful. That's for things like, most times in industry, you're going to find that people want to design something a safety factor of 2, so that it takes twice the force it would normally break to break in this case. As you can see, everything's at 15. This part's not breaking. It'll bend, but it's not going to break. Right? Now, what if I wanted to change the scale, right? Because it's kind of weird to say, oh, that's at, the KSI is 0.2839. All right, what does that really mean? Does that matter? Go to color bar right here. Click that. See visibility. You unclick that, click OK, it's not going to show you that bar. That makes things really useless. Don't do that. So leave that clicked. And then it's going to ask you to choose a maximum minimum. If you unclick this, you get to choose. If you click it, Inventor chooses for you, and it does it based off whatever the calculations were. So let's say we applied 5 pounds of force to this. That's going to change that. But in this case, we're going to unclick maximum. Let's say we're worried about anything getting to 1 KSI, right? Once I click apply, it'll scale everything to match what I just did. So that red spot won't be red anymore. It'll be probably like light blue or green. Click apply. Oh, it's really almost non-existent anymore. So you can see if we change that, it doesn't really matter. But it is also going to leave this cool little max thing right here. So we know exactly how high the strongest point gets. And you can see it's in the same place as the red was before. That's going to be your main topic to talk about. All right. Before I go on to the next part, it gets more in depth. Question. Like I said, the mesh is how the system calculates it. So instead of having to go say, all right, we're just going to calculate all of these at once, and we're just going to calculate an entirely separate piece, it makes it so that the mesh calculates each portion individually. So let's say, think about this point right here on the mesh, right? The system will just calculate that triangle, and then it'll move on to the next triangle, and the next triangle. And once it gets all of them, it'll attach them together instead of having to do them all at the same, all at the same time. So that's kind of how it works. In some other programs, I know in SolidWorks you can change the extent of the mesh, so you can make triangles really, really tiny or much, much bigger. I don't think this program allows you to do that, but I could be wrong. I think you probably can, but I'm not 100%. I haven't messed with it too much. Yeah, right here. OK, mesh settings. Really straightforward. All right. So I said before how there's like a parametric constraint, right? That's where the power of this tool really comes in handy. Let's say you're wondering what thickness you want this bracket, right? Can we just get away with using 16th-inch aluminum? Do we need to use 1/4-inch aluminum? Do we need to pick something in the middle? This is the feature that allows you to make that decision first before just guessing, right? We're kind of done with this. Let's get out of this. We're just going to delete it. All right, back to this page. Create simulation. We're going to change this to parametric dimension. Click OK. Same thing as before, right? Nothing's really changed too much. Let's go down here and click Assign. It's the same as before. Click Fixed Constraint. You have your pin and frictionless constraints too, so you can play around with those later. We only need a fixed constraint for now. You can click more than one face when you do a fixed constraint also. So if you want to click this face as well, we don't want to do that, but if you want to, you can. Fixed here. Click Apply. All right, back to our home view. Force. Right, so I said I was going to change that before, and we'll show you how to do that really quick now. If you click Finish Stress Analysis, it'll save all the stuff for you. You can come back to it later. So we're going to click that now. Exit out of the Stress Analysis tab. Create a sketch. We want to apply it as if there was a bolt and a washer through that, right? So we're going to come here, Project Geometry. Click right there. And let's say we're going to make this circle about, this is a big bolt, inch and 5. All right, cool. Click, there it is, split. So split is your tool at how to do this, right? So you click the split tool. That's going to be whatever your profile was, whatever geometry you wanted to have before. If I wanted a straight line down one side of it, you could do that. But in this case, we're using the circle. So click there. Faces should have already selected it for you, but we're really just looking for that one. Click Apply. As you can see now, if I click that face, it's no longer including that circle. It's a separate face to choose from. Even though, if you look at the part thickness, it's exactly the same. So there is a neat trick you can do where if you try to do that really simply, you can kind of come in and just extrude a really, really small portion of it out, but it looks really funky and you have to undo it later. So I really recommend using the split tool. It makes things everything easier and it doesn't really take away from anything. So go to Environments, go back to Stress Analysis, and you see it brings the simulation back. We didn't have to change anything. Our old constraints are there. Nothing too big. Go into Force. Oh, wrong face. Click there. Let's just use 1 pound. Simple enough. Click Apply. All right. So we're pretty much ready to go, except one thing. See this parametric table thing in the corner? I know you guys noticed it before, so probably going to wonder how we got there, right? Come up here, you choose Add Design Constraint. So what are we looking for? That's kind of the key here. So if we want to have a safety factor above, let's say 1.5, right? Click OK. What type of constraint are you using? Click, say you need to have a lower limit. We want it has to be above 1.5. Okay? Let's add another one. Mass. The mass of this part needs to be below, I don't know, 2 pounds. Sure, whatever. It doesn't. You can choose whatever here. add design constraint. Let's say we need the stress to be beneath, go down, choose the upper limit. We want it to be beneath, was it last time 0.289? Let's say we want it to be beneath 0.25. It's in KSI. Your units are all in the end here. All right, so that's pretty much it. But then you're going to come into here. Shoot. How did I get this before? I am sorry for totally blanking. There it is. Show parameters. Okay, so these are kind of going to be your dimensions that you're going to want. Everything that I used to create this part is right here. So if you rename things in the parameter name, that's going to be really useful, right? But in this case, you should be. There's a pretty simple part. You should be able to figure out what you're looking for here. In this case, we just want the thickness. So we're going to click that. Click OK. You can see it adds that. You can see the feature we're talking about, the thickness we're talking about, and the values, right? This is the flange. I'm not sure we want that. Let's say we want a different one. Go back here. This is the one. Up. You kind of scroll through the options. I think this is the one we want. Nope, that's not it either. Okay. Let's go with that one. Yeah, there we go. That's what we wanted. Okay. I can remove parameter and just use that one. So from a values perspective, let's say we want it with 0.0625. That's a 1/16 of an inch. Go with an 1/8 of an inch and a 1/4 inch. Right? Enter those values. Now it's going to kind of switch between them. So you can see if I drag the slider right here, it'll jump between the options. It'll only show in the model space the one that you actually have, but you can jump between the options. And why does that matter? So I'm going to kind of drag this up here. Okay. I'm going to go to simulate. Ready to run set of simulations. What can you notice here that's different? Instead of saying just simulation up there, it now says 3 configurations will be run instead of just 1. So as you can see, if I click run, it's going to take a little bit longer. That's interesting. It's not supposed to do that. But anyway, what it does create, it does allow you to do, is when you drag the slider back and forth, it'll change those values. And you can see the green circle right here. That's going to be your, like, hey, this meets your minimum requirements. As you can see, our safety factor is 15. Our KSI is 0.2215. So, and then, well, that's our mass. And then the KSI is 0.812452, whatever. First 2 digits. Anyway, so you kind of can see which ones meet our specifications. And then from that, you can pick which one's best for you. So this is an extremely powerful tool if you're doing some kind of force analysis. I can't recommend anything better than this. All right, that's pretty much it. Any questions? All right. I'm gonna keep considering this as a good thing. All right. Okay. So renders. Renders are a neat little tool. Like I said before, they're really useful for presentations. And you're going to find that the more you do this, the more kind of fun it is. How do you let's put our robot in the sky. Or let's put it with a red background. And it looks really cool, especially when you have complete CAD. So we're just going to use this assembly right here as an example. Go into environments. Instead of clicking stress analysis right here, go into Inventor Studio. You can see it's a little bit different. A little bit neat stuff. You can create animations out of this. We're not going to kind of deal with that right now. We're just going to talk about renders. And renders are a little bit more straightforward. Animations are similar, but renders are a little bit easier to make happen. So the first thing is if I just click render image, right, it's going to put up this pop-up box. Width and the height of your image, the camera, which view are you using, which lighting are you using. You can kind of change it up. So you can see the lighting changed a little bit. Background, you can kind of pick a background. So you want a galaxy. And then a render type, shaded or illustration. We're going to use shaded for right now. That's the more realistic version. Click render. a cool little image, right? You have your robot in a space. You can also add your custom images too, so we're going to show you how to do that. So we're done there. All right, pretty cool. So what if you want to do something a little bit different, though? Let's say you want to add your team's custom image, right? You can kind of come in here, choose a gradient background. You can kind of switch up the colors. So let's say we want to go, I don't know, let's pick tech colors, because tech's awesome. Is your navy and yellow? That's one option. Or maybe we want white and yellow, or white and navy. You can kind of do whatever you want and kind of play around with it. So it can, especially if you have really iconic team colors, that's really useful. I find whenever I did kind of renders for my own team, red and white were our colors, and we use that a lot. So it could come out really well. You can kind of change up what you want here if you want an image or not, but generally what you're going to kind of stick to is just using the general gradient or creating a new image. So no, we're not going to save the style. Going to come back to the scene styles. It's back to normal. We're going to create our own new style, though. Right? Let's say you want to go get an image. You can kind of choose what you want. It's got some backgrounds for you. You can also go into pictures. Let's say we want to use this background. Okay. Sometimes it'll reject it based on what size of the image you have. Pictures. Actually, to make life easy, we will just pick a regular image. Let's say you want to use these clouds in the sky. You can kind of do that. It's really simple. You just want to save your option. Kind of double click, click save. All right, and if you go into the render image again, you can select that's not the right one. Your default, click render. Does the translating thing, it kind of creates that face. Now you can see it's kind of underground, right? You can see the shading right here, but it's not really exactly what we want. Again, it's something defined in scene styles, right? So if you position it in the center, then when you create this image, it's going to center it on it's going to use this work plane, right? That's going to be your image. But then if you use the tile, it's going to kind of place it around. So if I click OK, save, render image, creates a little bit of different. You'd still see this right here, but it's not exactly what we want. Go into C styles. Here's where you change that ground plane. So then let's say we wanted to use a little bit different. We wanted to show the entire part. We choose current because that's going to show everything. We want it at the base level. So we can click OK. If you want to if you don't want to have shadows or you don't want to show reflections, you can turn them off. Let's say we want shadows only. Click save. Done. Render. Does the same kind of thing. But now you can see the bottom part. So you have a lot of options to play with. Like I said before, if you want to change the width and ratio, let's say we want to make this much wider image. Click render. And now it does it. A ton of options to play with. I would recommend, it's all personal opinion, which one you like better. But I really recommend going through and playing with these on your own, because it's going to be, it creates some great material when you can take images of subsystems or your entire robot and take that back to your PR team and say, hey, we have these images. Let's create an amazing PowerPoint. Because it really does make a difference, I can promise you. All right, let's click desktop, render. You can see it creates a completely different look. All right, like I said before, I'm going to let you guys do your own animation stuff. That's a lot more complicated than I have time for right now, but it's pretty cool. All right, I think that's pretty much it. I don't really have too much else to cover. Does anyone have anything specific they want me to go over? Any questions you guys have from before? Okay, cool. So I set up my emails right here. I'm going to be here for about 30 minutes after, so you guys have a different question, much more specific. Simple question, you can come here and ask me that. And if you want to ask me a question in email, I work normal hours, so if you send me an email at 3 o'clock and I don't respond by 4, calm down, I'm still at work. But otherwise, I should be able to get back to you the next day. All right, that's it.
Can we give Trevor a round of applause? Thank you all so much for coming to the RoboJackets TE session on CAD. Personally, I would suggest that you go home and try all of these things yourself. These are on RoboJackets YouTube channel, our archives, so if you miss something, you can always go back and look. Honestly, just when you're home sitting at your desk with your laptop or your desktop, just take something and CAD that. Practice something once a week to CAD. That's how you get better at CAD. You can watch as many tutorial videos as you want. You can ask as many questions, but until you do it yourself, you won't really learn how to do it. And we want you to be prepared for this next season. And so this is the way to do that. And again, thank you so much for coming. If you have any questions, we'll still be here. Trevor will be here for a while. Come back next week where, is Fernbank? Fernbank is going to teach you guys how to do FRC Java next week. So that'll be here again Saturday at 6:30. Thank you.
I don't know why that parametric dimension didn't work. I did that before. Oh.
First off, should we stop?
Yeah.
No, he says to wait. I think I blew everyone's ears out for a second. Because your mic was, no, I did. Because like the mic was low, so I turned everything up. Like it was just